Today, we're going to pull back the curtain on a language that for, 50 plus years has been the quiet, invisible foundation of our digital lives. It's definitely not flashy, but trust me, without it, the modern world just wouldn't work. We're talking about the C programming language. So let me start with a question for you. Think about your computer's operating system, the web browser you're probably using right this second, and even the complex software running inside your car. What do they all have in common? What's the invisible thread that ties them all together? Well, the answer, in a shocking number of cases, is C. It's this powerful, super efficient language that really forms the bedrock of almost all modern computing. And to really get why, we need to jump in a time machine and go way back to the beginning. To really understand C, you've got to know it wasn't born in some university lab as a cool theoretical idea. No, it was forged in the trenches, a practical tool built to solve a massive, immediate problem.
And here is the absolute key. C was created with one single-minded mission: to build the Unix operating system. See, before C, operating systems were written in something called assembly language, which is this really complex code that's tied to just one type of computer. That meant if you wanted to run your OS on a new machine, well, you had to rewrite the whole thing from scratch. C was designed to completely shatter that limitation.
And don't just take my word for it. This quote from the creators themselves, Brian Kernighan and Dennis Ritchie, just drives the point home. They imagine this entire ecosystem built in C, not just the operating system, but the very tools used to build software and the software itself, the whole shebang, all speaking the same efficient language.
So where did this game-changing language even come from? Well, it didn't just pop into existence. It was actually the result of a really clear and surprisingly fast evolution that was driven by very practical needs at Bell Labs.
You can actually trace its family tree pretty clearly right here. C's story starts with an earlier language called BCPL. From that, Ken Thompson over at Bell Labs created a simpler version he called B back in 1970. But B had a huge problem, a really critical flaw that pushed another Bell Labs genius, Dennis Ritchie, to create its much more powerful successor, C.
Okay, so what was this big flaw with B? Well, B and its ancestor BCPL were what we call typeless languages. Now, think of it like this. They just saw all data as one generic pile of stuff. They couldn't tell the difference between, say, the number 65 and the letter A. And for a really complex system like an operating system, that kind of vagueness, it just wasn't going to cut it. You need precision. This is where Dennis Ritchie had his big light bulb moment. He introduced data types into C. So now the programmer could explicitly tell the computer, hey, listen up, this isn't just stuff, this is a character. And this is a whole number. This over here is a decimal. This might sound simple, but this one addition was the key that unlocked the raw power and blistering speed C is still famous for today.
Every programming language kind of has a personality, a philosophy that guides how it's designed. And C's philosophy is really what's made it so incredibly powerful and long-lasting. It's all about simplicity, power, and trust.
This quote from the creators just perfectly captures the spirit of C. It's not some massive, bloated language that holds your hand. In fact, its power really lies in what it doesn't do. By staying small and getting rid of restrictions, it basically just hands the keys to the kingdom directly to the programmer.
So what does low level actually mean? It means C speaks the language of the machine itself. It deals directly with the basic building blocks, characters, numbers, and memory addresses. It's kind of like being a mechanic who works directly on the car's engine. Higher level languages, they're more like being the driver. They add all these convenient layers, which is great, but you're much further away from what's really happening under the hood. And this all boils down to one core philosophy. C trusts the programmer. It assumes you know exactly what you're doing, and it's not going to put up guardrails to stop you from doing something potentially dangerous. The trade-off is this. With that huge responsibility comes just incredible power and control. It's a language for builders who really want to feel the metal.
So, C's success actually created a brand new kind of problem. As it spread like wildfire from Bell Labs to computers all over the world, different versions started popping up. And this threatened the very thing that made it so valuable in the first place, portability.
Yeah, it was kind of like having dozens of different dialects of English. A program that you wrote on one computer might not work at all on another. It was a mess.
If C was going to fulfill its promise of being this go-anywhere language, it desperately needed a single official rulebook that everyone agreed on.
The big turning point came in 1983. That's the year the American National Standards Institute, ANSI, stepped in. They put together a committee with one critical mission: create one single, official, machine-independent standard for the C language.
And the result, which we know as ANSI C, was just a massive leap forward for the language. First, it locked in all the formal rules. Second, it introduced new ways of writing code that helped catch common errors before they turned into nasty bugs. And third, and this is huge, it established a standard library, a common toolkit of essential functions that every C programmer could rely on, no matter what kind of computer they were on.
So why does a language from the 1970s still matter so much today? Well, it's because its core principles, that raw efficiency, that portability, and that direct control over the hardware, they're just timeless. In fact, you could argue they're more important now than they've ever been.
The authors themselves even reflected on this years later. In a new edition of their famous book, they said C wears well. And I love that. It's like a really well-made leather jacket. The more you use it, the more you come to appreciate its design and its craftsmanship. It's a language that truly rewards anyone who takes the time to master it.
And, a huge part of its lasting appeal is just its size. Compared to some of the massive, complex languages of today, C is this compact, elegant toolkit. A single programmer can actually reasonably expect to understand the entire language. That level of complete mastery is almost unheard of today, and it gives you this fundamental understanding of how computers really work, right down to the silicon.
History, it is a living, breathing part of our present. It's the language that built our digital world. So the real question is,